I have a gather volume and I want to understand the amplitude variation with offset at an event. Zooming in, I can see the event here. The wiggle overlay really highlights the change in amplitude. If I turn on the amplitude graph, I can see the values across the gathers. The first panel shows a clear increase in amplitude, and this is interesting, but the other panels show inconsistent and negative amplitudes. The graph displays the amplitude at a constant time, and this misses the event in other gathers because of changes in structure. I don't want to investigate one gather at a time, so instead I will pick the event as a gather horizon. The interpretation can follow the structural changes and any residual move out in the gathers. For the best results, I should interactively pick some gather seed horizons and use Insight's automated propagator, but for now, I just need something fast and simple. I have a horizon already interpreted on a full stack volume. Creating a gather horizon from this stack horizon will take only a few seconds. The stack horizon is here in the map view, and you can see the intersection displayed on the gathers as a red dot at offset 0. It ties the near offsets nicely and does a good job of following the variation in structure. Using a map operation, I can create a gather horizon by extrapolating the stack horizon across the gather. The input horizon provides the vertical position, and I provide the gather type, range, and increment, which can be found on the Volume Details panel. There, taking only a few seconds to create, the new gather horizon is the flat line across the gather, starting at the 0 offset intersection. The thicker orange amplitude graph shows that the extracted values are much more consistent compared to the thinner red constant time extraction. This would be a great solution if these gathers were perfectly flat, but I can see a small amount of residual move out. If I track the event exactly, I can improve these results even further. In an ideal world, I'd have the time to flatten the gathers with some RMO correction. I could even interpret the horizon across the gathers using the automatic horizon propagator. But let's try a faster workaround. Using the snap horizon operation, I can shift the picks to land on the peak amplitude. Check the gather horizon is selected, and then the gathers. I'll set the window parameters to largest peak with an asymmetric search window based above the event and constrain the output to my area of interest. There, that's better. The subtle changes in amplitude can be seen on the thick purple amplitude plot when compared to the original flat orange horizon. It would be wise to QC a few other locations to make sure the snap function has worked well everywhere. The snap process can be run again as a second pass to constrain any mispicks. Once checked, the gather volume can be selected in the map, and the offset amplitude can be extracted on the fly to determine the lateral continuity of any observed anomalies. I can interactively drag the offset location in the gather view from a near to a far offset. That's interesting. The increase in amplitude observed in the first gather location seems to only occur in the southern part of the dataset. Elsewhere, the amplitude decreases with offset. This is exactly the information I've been looking for.
If you have questions or would like to discover more, then visit our website at www.dug.com. And remember, have fun with Insight.